Okay, so here are our notes. We're gonna start off with, I guess actually let's just do boxes 10, or wait, 7, 10. Here, let me highlight the boxes so you know what I'm talking about. We're gonna do this box, this box, this box, this box, and this box, and this box. So like the edge boxes, okay? All right, so let me remind you first of all about sine's ratio. So sine, which is spelled S-I-N on the calculator for short, sine is opposite over hypotenuse. Now, if you ever forget that sine is opposite over hypotenuse, there's this phrase called SOHCAHTOA, which is written on the side. You can see SOHCAHTOA on the side. The SOH in the SO stands for sine opposite hypotenuse. That's S for sine, O for opposite, H for hypotenuse. So sine is opposite over hypotenuse. We've learned to solve for missing sides using sine, but now we're also going to learn how to solve for an angle using sine, and that's in this box over here. So if you direct your attention towards box number 10, we're going to learn how to solve for an angle. So let's say we're looking for that x on the very bottom, that angle. And we notice that, okay, if x is our reference angle, we have the opposite side. And we have the hypotenuse. Hypotenuse is directly across from the right angle. And so we have the O and we have the H for opposite and hypotenuse. That would mean we're using sine. So sine is opposite over hypotenuse. So you can see they put sine of x degrees is equal to 23 over 26, the opposite over the hypotenuse. Then on the calculator on Delta Math, you would type in this, sine inverse of 23 over 26, so that you can get your angle. And then Delta Math will tell you the degree. It's 62.1 degrees. So that's how you would do solving for an angle. And of course, we will do some examples together in Delta Math later on, but here's the notes for it first. Are there any questions on this box? All right, please interrupt me at any moment if you need to. Let's do the cosines. So for cosines, we have the ka part of the SOHCAHTOA, okay? So C stands for cosine, A stands for adjacent, and H stands for hypotenuse. And so that means cosine is equal to adjacent over hypotenuse. And so we've used cosine before to solve for a missing side. Now we're going to zoom in on this box to use cosine to solve for a missing angle. So if x is our reference angle on top, we know that over here is our hypotenuse because it's directly across from the right angle. And then the 21, that happens to be adjacent because it's directly next to x. It's adjacent to x. Adjacent means next to. So this is the adjacent side. And so we have the H and we have the A, so it's SOHCAHTOA. The ka part has adjacent over hypotenuse. Cosine is adjacent over hypotenuse. And so they put cosine of x degrees is 21 over 32. And so typing it into your calculator, if you want the angle, you type cosine inverse of 21 over 32, and the calculator will give you your answer, 48.99 degrees. Are there any questions on this one? Okay. The last box is tangent. So tangent is the TOA part of SOHCAHTOA. The T stands for tangent, the O stands for opposite, the A stands for adjacent. So tangent is opposite over adjacent. That's what TOA stands for in our SOHCAHTOA word. All right, so with that in mind, we're going to use tangent to solve for an angle. We've already used it to solve for sides, but now we're looking for an angle. X is our reference angle here. We have 8 being our opposite side because it's directly across from our reference angle, so it's opposite. And then we also have 25, which is directly next to x, and so this is our adjacent. And so we have the O for opposite, the A for adjacent. This is the tangent. Tangent is opposite over adjacent according to Soga. TOA, T-O-A, opposite over adjacent. So tangent is equal to opposite over adjacent, and you can see we put it together. Tangent of x degrees is equal to 8 over 25. So you enter it in on the calculator with the tangent inverse button. Tangent inverse of 8 over 25 will give you x. The calculator tells us 17.74 degrees. So our answer is 17.74. Are there any questions? Okie dokie. So I'm going to end the notes here and then let's do some delta math examples.